Okay, thank you for the introduction, and thank you again for Professor Michael Bates to invite me for a wonderful workshop. It is the first time to escape from Japan after the COVID-19, so I'm very excited to discuss with you in person style. Okay, so my talk, the title is a digital twin system that extends the human and robot experiences. And I belong to National Institute of Informatics and the other university named the Graduate University for Advanced Studies in Tokyo. Hi. The first of all, my ultimate goal in the robotics field is to realize such a personal assist system in daily life environment and some acquirement of the personal model to adapt to the each users. And the approach to the final goal, I am now titled such a concept like experience shareable robots. That the robot can share the long life experiences in daily life environment and to make the robot more intelligent. At the same time, the human adapt to a robot or human enhance their human enhance the quality of life like that. So towards such a final goal, today I'd like to propose a little bit novel keyword like a VR digital twin. And this VR digital twin, this is just a combination of virtual reality and digital twin. This field is for the robots to efficiently gain the experiences and quickly acquire user adaptive behavior. But this is some requirement. But this is a very conventional and standard usage of the robot simulator. But not only to make the robot more intelligent, but also the cognitive support for human. For example, such as visual guidance, audio guidance, or language navigation is provided by the digital twin system. Not only physical support, but this is my ultimate goal. So today, I'd like to explain my future plan, how to apply such a combination of virtual reality and digital twin. I guess yesterday, Michael have made a lecture on the digital twin and simulator, right? So it might be duplicated, but I'd like to start from some introduction of what the digital twin is. Then, as you might know, this keyword is used in the product life cycle management system on the very huge product like an engine or a nuclear plant and so on. And my definition is introduced and copy and paste from Wikipedia. But to maintain and modify the internal state of such a huge product, that is very difficult. So making a digital twin as a copy of the real product, and real time the sensing the status of the real product, and analysis or simulate what will happen in the next moment in the virtual space, and some suitable feedback should be back to the real product. So then this is one of the typical definition of digital twin. But the more to analysis the type of the digital twin and the category of the digital twin, some researchers propose several levels and several types. This is a type, 4 type. DTP, P is prototype, DTI, I is instance, A is aggregate, E is environment. But this is a low level and this is high level. The prototype is just a prototype before using the real product. But instance is connected to the real product, and the digital representation of each product is represented in the virtual system. But this is a kind of simulator. And aggregate, this third type is a set of instance. It means a kind of metaverse of object. So many objects gather at the same virtual space, and we can analyze some interaction between several products. This is DTA. And DTA is environment that include a feedback system, real-time feedback from the virtual reality to the real product. So this is the 4 kind of type. And another level, this is another definition, but the model, shadow, and twin. So before digital twin, there is 2 models, 2 levels. The digital model is disconnected from the real world. So it means some engineer analysis the real product and copy to the digital twin virtual reality system and just analysis in the virtual reality. That's all, no feedback. But digital shadow is the feedback is realized. But the feedback is not automatically. The engineer or researcher, some manager, analysis the digital status and make a feedback to real product by manually, not automatically. This is the digital shadow. And finally, digital twin can realize the real-time feedback, automatic feedback, and some system can intervene and to modify the real product. This is the 3rd higher level digital twin. So we can use these types and level to analysis the current virtual reality or digital twin or some combination of these technologies. So, for example, these are several related applications to robotics. For example, this robot simulator, how to grasp, how to manipulate the object. This is one of the very typical and standard usage in robots. We can say that this is the digital shadow or digital twin. And DTI instance is just a simulator for one robot, just one sole robot. But for example, this is in the famous usage in the Google. Each experiences on each robot can gather at some centralized representation system. So we can define that kind of set of digital instance as DTA aggregate. And for example, that is automatic driving system, always sensing the real environment where the other car who are working across the cross point represent all the status in the digital twin system and feedback to the real car. So we can say that this is the digital twin system that can realize the real-time feedback, real-time modification of the real product. And another one is some maintenance system or analysis of the plant, like a nuclear plant. But this is the model and prototype. Before using the real product, analysis the status or analysis the future state. And engineer make a feedback, not automatically, but manually. So several application could be analysis by such 3 levels and 4 categories. So in the case of the automatic driving system, we can say that almost all the robot system, like a simulator, is a digital twin. Always sensor the outside environment, and always real-time the status is reflected in the virtual space, digital twin system, and always control and predict the future plan and to feedback to the real robot system. So we can say that almost all such a robot system simulator could be categorized in digital twin system. But I think towards the assistant robots, assistant of the real human, I am a little bit not satisfied with these very useful tools because almost the robot simulator lacks the presence of human and activity of the human. That is lacking in that kind of useful tools. So this is my motivation why I want to integrate virtual reality and digital twin. So it means the object is the mainly target of the current digital twin, like an engine, nuclear plant, or robots. But I'd like to extend the target of the digital twin to human. So In other words, the human digital twin. This is my motivation and the direction. Of course, recently, human digital twin, this is a new keyword. This is gaining attraction. For example, like a metaverse playing in the virtual reality as an avatar, using motion capture, facial capture, and not only the motion capture, but also sensing the vital signals and the reflect some status of the emotional state on the avatar. Such a system is very attractive and gaining very attention recently. And not only physical motion, but the mental emotion, feeling, gazing, which direction the human concentrate on, or what kind of awareness, behavior like a history of buying, watching YouTube history. That kind of preference is one of the target of such a human digital twin. So, but in terms of the real time or not, automatically or manually, so many applications are gaining attention, but the current status of the human digital twin is a mix of the different levels, like a model level, shadow level, twin level. So, of course, the final level, digital twin, real-time automatic feedback, this is the ultimate goal. So, metaverse or some life log. Life log is one of the typical standard shadow and instance. Not automatic feedback, not just the user's thing. For example, I'm always wearing such a ring to measure my activity, like a sleeping status, and I always watch the smartphone. You slept about 7 hours or 5 hours is too short, so you should sleep tonight, okay? Then I will control by myself. The system can show just the information on the screen, but I have to check the screen and I have to control by myself. This is the shadow. But in the case of the human-robot interaction, of course, assistive robot should guide and navigate the human by some suitable way, not only just showing some message to the screen, but some real-time feedback, not only just the information, but some friendly and awareness feedback. That is very important to realize the ultimate goal of the assistive robots. Okay, so this is the current status of the human digital twin. Then, for example, this is not the use application in the robotics, but one of the cutting-edge area of the human digital twin is the virtual reality-based rehabilitation. For example, this is my some collaboration with medical doctor to apply this AR rehabilitation for hemiplegia patient who is difficult to move their hands or limb. Then measure the EMG and predict the human intent and showing you are now doing such a grasping or reaching movement and showing such a real, not real, very realistic motion on the human's image. Then patient can, okay, so this is my intentional movement. So cognitive support should be input to the visual feedback, and the patient status will be recovered by such a AR-based rehabilitation. This is just one of the example, but the VR rehabilitation is a very, very big field and the expected social impact. Okay, but this is one of the typical application in the human digital twin. And this is very old, my past research, but the sports coaching, this is one of another human digital twin to measure the human's motion and detect and analyze what is the wrong point, what is the gap between the ideal motion, and make a feedback. Your motion is not so good, so you should do like this, or you should bend your knee more like this. And this is very simple, my past research, but measure the human and real-time analysis and model the personal model. And what is the best feedback, what is the best enhancement for the human. Not only the visual feedback, but the utterance, to use a very simple natural language, but the language navigation and generating some enhancement, what you should by the visual feedback. So combination of such a visual feedback, utterance feedback, and the personalization can improve the motion learning ability. For example, this is, I think, the one of the human digital twin. Anyway, so summarize my introduction. I took so long time, but the digital twin for human-robot interaction, this is a missing area in the current cutting-edge technologies. For example, this is a robot object digital twin, a robot simulator or robot controller, and several three levels. Model shadow twin. This is real-time feedback, manual feedback, and no feedback. Then this is the human digital twin, like analysis of the human motion, like ergonomic analysis in metaverse or VR rehabilitation. But I think this is missing area in human-robot interaction. We can analyze and we can modify the robot strategy, how to deal with the human activity by simulator or some digital model-based application. Like this picture is different from the Omniverse. NVIDIA recently proposed the Omniverse, and Omniverse can say that some collaboration between human and robot could be analyzed in the Omniverse system. But I think this is not the automatically and not the real-time feedback. The engineer who used the Omniverse analyzed this level of the optimization of human-robot interaction, and, for example, design the place of the robots or some plant design, then feedback to real environment. So this is manual. So automatic and real-time feedback for human-robot interaction is very, of course, several application is proposed, but I think this is the future missing area. So recently I developed this kind of platform that can combine the robot simulator and the virtual reality system on cloud computing environment to approach to the missing area on the human-robot interaction digital twin. So this is the virtual reality system that can invite the general people in the robot simulator in cloud environment. So for example, this is some movie for the human-robot interaction in the VR cloud environment. So this is named Sigverse. You can download or Google what the system is using the Sigverse, the first line. But this is the combination of the Unity and ROS. You may know both of the framework, but Unity is very easy to invite human to virtual reality and combine and making a bridge between Unity and ROS. So in other words, the system can invite the human to robot simulator. And of course, this is very easy to record all the event, all the behavior, all the sensor signals in the virtual reality. So we can reproduce what kind of event, what kind of experiences will happen in the virtual reality, not only for the robot signals, but the human's behavior. Both of human-robot experience is able to be stored in the cloud-based system. So this is the characteristic of the Sigverse system. So this is one of the simple example, very conventional and simple example to apply for the imitation learning. But this is the robot learn how to washing dishes, then making a virtual kitchen. But this is very similar to, I think, the Michael B's laboratory. but using the virtual devices and collect so many strategy how to clean the dishes by several subjects. Then this is just a typical 10 different models and extract this strategy, how to use the tools or order of each primitive actions, then extract this common part, what the users do, what kind of object, what kind of order of the primitive action, and find some common knowledge graph representation, and the robot can use that graph model to imitate the dishing, washing a dish behavior. And one of the advantages of this system is the same environment, same situation could be provided to all the participants in worldwide. Well, actually, this is a collaboration with Professor Gordon Cheney at TUM. So the many test subject can join from Japanese side, from German side. So many people can log into the same soul environment. So this is one of the usage of the digital twin. But of course, this is very simple. Just robot learn how to wash the dishes by humans demonstration. So this could be realized in the real environment. So I'd like to progress to the another application, the feedback to human or using the experiences of human side. Okay. I think I finished around 30 minutes. I have to hurry up. So another application is the robot competition in human-robot interaction. You may know the RoboCup at home. This is one of the type of league in the RoboCup, not football, not rescue, but at home is another league. But this is as shown in the movie. This is human-robot interaction in daily life environment. This is the target of the RoboCup at home. The human test subject instruct by natural language, please give me a coffee or bring my milk, that is in the refrigerator. So understand the natural language instructions and of course recognize environment, navigate, manipulate, grasping. So many fundamental functions should be integrated at the robots. So, but this is one of the typical challenge and evaluate and progress the cognitive robot function in daily life environment. But this competition, as a competition, that has some pros and cons. For example, this requires so many function and complex tasks. Then this is very important to deal with the complex everyday life environment, but as a competition, this is very time-consuming, so long time. For example, 10 teams or 20 teams have to gather at the same venue, but we can provide just one field. So please come here and 10 minutes task, 10-minute challenge, and switch to next team. So more full day, like a one day from morning to evening should be spent for the competition. And of course, so many teams participate, just one-shot evaluation, like 5 minutes or 10 minutes. So this is very difficult to evaluate statistically and impartially. So many teams participate gather at the same venue. So test subject always gave, please give me milk, please give me milk, please give me milk. So many repetition of the interaction, but from morning to night. So sometimes the outside is bright, but in the evening part, the lightning condition is changed from the morning. So very difficult to keep the same conditions. So statistically evaluation is very difficult. Okay, so how to deal with that kind of disadvantage? Then solution is using the virtual reality and digital twin. So I launched the RoboCup at-home simulation using the my platform. Then we always use such as real environment, using real restaurant. We have to rent a real restaurant and bring all the robots, and so many people attend as a customer role. So long time, but we can change the real environment to digital twin system. Then parallelly, we can, of course, we can conduct several sessions at the same time parallelly. And one of the advantages is provide the same condition, writing condition, and some perturbation of the gesture or instruction, or sometimes the speech signal, speech utterance is a little bit different from the original pronunciation, or please give me a milk, or some such a noise, or some fluctuation of the utterance could be provided to all the teams. So this is the one of the advantage using the virtual reality system. So I made designed several interactive competition in the virtual reality, like using this handyman task is receiving the natural language instruction, and how to deal with some mistake of the human's instruction. For example, please give me a milk in the refrigerator, but the milk is not in the refrigerator, but just set on the table. So how to deal with such a mismatch of the human's instructions. Well, this one is interactive cleanup, just a combination of the gesture, working behavior, and please grasp that trash and then away to that trash box. For example, such a gesture, working behavior, and instruction by natural language. The combination of such a complex instruction is the target of the second task. But very attractive, and my main proposal on this simulation is the human navigation. But this is kind of opposite of the visual language navigation. So recently, visual language navigation is a typical task in the AI system in the daily life environment. But this is the robot give a guidance to human, and human follow to the guidance. But this is a little bit strange, but in the daily life environment, to suitable collaboration and cooperation with human robot. For example, this is a situation that the robot is too short, and the robot want to take the object on the shelf, but this is too height. So could you help me? And I'd like to take some object hidden in this black paper bottle in the second cabinet from the right. So the robot have to make a very friendly expression, not to human confused. What do you mean? The second from right, left, black, white? I don't know what you want to do. So this is how the robot can generate a natural and friendly expression to guide a human. So this is the opposite of the visual language navigation. So this is very interesting task for deal with the human experiences. Then actually, this is very complex task, but the usage of the virtual reality, digital twin, is a very attractive and useful. So I made such a system to invite the test subject to virtual environment, and the robot gave an instruction to general public people who who just came to the robot competition task. So could you join and could you enjoy the interaction with robots? So we can invite them in the competition. So, but this is just the showing the time-consuming task. But fortunately or unfortunately, this recent 2 years, we can apply this application platform to deal with the coronavirus pandemic. So many robot competition was postponed or stopped. But we can apply this application using AWS to provide so many participants in worldwide university. Then they can just submit the software to AWS, and actually real participants have to wear the real system to join this system. But we design the synchronization system of the offline home environment and AWS environment. So it means you should submit the robot software on AWS. Then test subject join to the competition from home, their home. Then a kind of synchronization system between AWS and home environment, they can interact with the virtual robot. The virtual robot software was submitted by competitor. So we can do such a competition, human-robot interaction competition, only from their home. So organizer, I organized this competition, but I operate all the system from my home last year. So that is another usage of the cloud-based virtual environment. But this is just the competition application, but another usage of the cloud-based system is the utilization of the data set of the human-robot interaction. Of course, this is a virtual reality, so every behavior event in the virtual reality could be stored in the database. So we can use that data set to so many kind of applications. So today I'd like to introduce just one of the usage of the data set stored in the virtual reality. So and one of the problem of such evaluation in the competition is the subjective evaluation. Assessment should be subjective or objective. This is a problem. For example, grasping object or reaching to a destination, this is very easy to evaluate objectively, just sensing just observing the robot behavior. But for example, in the case of the human navigation, what do you think about the quality of the explanation? How friendly the robot utterance is? This is a target of the evaluation. So this is very difficult by observing the robot sensor. So the conventional method was questionnaire using some score, like a Likert scale. How do you feel? How do you confused? But this is very time consuming, of course, and real-time feedback is very difficult. So I try to extract the model, how the human feel the subjective evaluation, how friendly, how natural the robot behavior is, using the data set stored in the virtual reality. Actually, I write the rule book, a kind of criteria of the score sheet. For example, if the time is spent 5 seconds, the score is decreased. Or if the robot collide with wall, of course, the score is decreased. Like some if-then rule. I write all the if-then rule to grade the interactive quality. But of course, this is a limitation. So I made the effort, a strategy to collect the subjective grade from the audience, public people. I asked the general people to evaluate how friendly, how interactively the human-robot competition is by crowdsourcing. Of course, this is a kind of questionnaire, but all the event, all the experiences was stored in the database, then we can easily reproduce by virtual reality. So test subject evaluate the quality of HLI, in the competition, then store the set of the behavior and the subjective rating. Then analysis between the subjective rate and all the data set. Okay, so I have to hurry up. Then, some paper information is appeared at the last here. So please check the detailed method and algorithm in the paper. But I made some candidate factors like time, how many words, how many gestures, or how often the human waving his direction of the head. It might be connected to the confusing behavior. So several 14 or 15 factors I design and extract from the data set, and using the multiple linear regression analysis, the relationship in the subjective rating and the objective event happen in the virtual reality was analyzed, and we can extract some coefficient to approximate the subjective evaluation criteria. Okay. Then this score graph shows that my rule book written by organizer was not much to the subjective feeling, but this is the score assessed by the general people. But this means the 7 teams and the score of the top team, the score of the second team is the same as the rule book, but the third and fourth team's evaluation score was different. So it means my rule book is not so good. And then evaluate and analysis the human's subjective feeling and apply to the revised rule book. Then this rule book can reflect the subjective feeling. So it is a kind of the, not automatically, but the suitable designing the rule book, not defined by organizer. So this is a kind of very fair strategy to design the evaluation criteria. Okay. So this is another one of the application to use the VR digital twin. Of course, this is the robot simulator, so so many experiences could be applied for the robot. So robot ability, robot running, we can do the robot running process in the virtual reality. And as I explained it, the human navigation, real-time feedback for the human, how friendly, how natural feedback should be given to the human. But this is the another opposite side of the experience, enhancement of the experiences. So this is the one of the very important field to store the data set of the interaction and apply for the both of robots and human. Okay, remaining is about 10 minutes. So sorry, my talk should be hurry up to the second part. The second part is different, almost different from the robot competition. But this is the spatial concept acquisition. Not only the concept, but the lexicon and concept acquisition from the natural human-robot interaction in virtual reality. So this is a little bit related to the previous talk by the concept, how to extract the concept and how to deal with the concept in the computational model. So, but this is the application to acquire the spatial concept and how to refer that space by natural language. And the assumption of this task is at the first time the robot doesn't know anything, nothing, like a dictionary or lexicon, no dictionary, and no map. Of course, the map representation could be acquired by SLAM, but at the same time, the robot can learn the concept in the lexicon by natural interaction. for example, this is some example of the express interaction between human. So you are now here in the conventional hall or in front of the elevator, or this is restroom number 1, blah, blah, blah. Then some very natural and interaction by natural language, and SLAM and sensors, vision, audio, auditory, and control signal for the navigation should be integrated in the graphical model. So this is quite complicated, so I will skip the detail. But this graphical model shows some combination of several modality. So this is a SLAM, a kind of SLAM to represent the place and relationship in the control signals and internal state. And this is the visual signals given by, captured by camera and extract into the autoencoder. And another one is the speech signals captured by microphone, and not using dictionary, but the dictionary information, word information representation should be acquired by the interaction. So speech signal, visual signals, and this is the two-dimensional distribution and SLAM. It is too complicated, but several modules are combined as a graphical model, just a probabilistical generative model. Then through the interaction, the robot can acquire the relationship in each parameters, and the central, this node is the concept. What kind of concept the human use in the daily life environment. Then, this is real environment, but using the SLAM technologies and utterance interaction by natural language is skipped, but the stored this is a representation of the spatial concept through the interaction. So now the fourth space concept is constructed in step by step. So many concept words acquired, even though the researcher not given the dictionary information. And this is another movie that shows the feedback to the user. This is solely that the text is in Japanese, but the showing the probability and the distribution of the concept, what you used in this area. Then the human can easily understand the current status of the conceptual internal state. Okay, so 98% is kitchen. This is right, but you might misunderstood my instruction or speech guidance. This is not kitchen or blah, blah, blah. Easily, the robot, a human can detect some missing representation in the internal state and make some feedback to robot. No, you are wrong. This is called as kitchen, and the restroom is there, for example. This is another device, not virtual reality, but the feedback to user, and some friendly and effective interaction could be realized. So the time is limited, so I will skip several slides and going to the next topic. But not only the real, but we can design so many different virtual environment and doing the interaction experiences in virtual reality. So transferable learning or acquire the concept in the one data set and apply to another data set. This is very easy to be arranged, not using the real environment. Okay. So then I'd like to go into the final topic about towards the humans' behavior change. Mainly the robot control robot navigation was the main topic in the two application. But this is the ongoing project to how to make a more effective feedback for the user to changing the behavior in daily life environment. And this is ongoing project led by Toshio Fukuda in Japanese professors. Then, but assisted robot, to say simply, this is the realization of the assisted robot. But the key concept is not only the physical assistance, like a rehabilitation, but the improve the user's self-efficacy. This is the key concept of this project. I guess the self-efficacy is not so standard keyword in robotics field, but the self-efficacy is a keyword that shows some grade or level of the human subjective belief that I can do this task or I can deal with this problem for the future. That kind of level of confidence. This is a keyword in the psychology. And if the self-efficacy was low, that human tends to hesitate to try to challenge the new task, and a kind of displaced status became to be users. And if the self-efficacy was high, they can think, I can do it by myself. Then how to deal with that human's mental state, and what kind of support is effective to guide a human, make human self-efficacy higher. This is a very challenging, and I don't know whether I can do it, but a kind of some new challenge project. Then how to behave to improve the user's self-efficacy. So, and this one of the strategy to improve the self-efficacy is using virtual experiences. So this is just one of the start example, but I choose the VR juggling task. And this is very complicated and very difficult. So many users feel low self-efficacy. This is difficult. So I cannot do that kind of complex juggling. But this is virtual environment, so we can generate the virtual kind of fake experiences. In the real behavior, real skill, the juggling is not succeeded, but we can modify the trajectory of the ball or the successful experiences could be modified, even though the skill of the user is not so high performance. Then, this is just a virtual juggling, but I made several experiments, and this is one of the the first step experimental result, but now this shows the coefficient, correlation coefficient between self-efficacy and the several factors. The factors is number of success event, number of failure, number of success in memory. In memory means, so what do you think about the last session? How many times you made success? Please remember the number of successful experiences like that. Then the time is not so remaining, so I will skip the detail about this one. But one of the strong relationship is a sense of agency. Sense of agency is also, you might know the keyword, but some cognitive feeling of the human subjective. So I do this performance. I control my arm. The sense of such an agency is called as sense of agency. But this is the more strongest factor in the self-efficacy. And this is very interesting that number of failure doesn't have the correlation between self-efficacy, but the number of success or number of success in memory has a strong coefficient, but in the self-efficacy. So it means it is important to provide the user don't worry about the failure, but rather build their one successful experience to improve self-efficacy. That is one of the life direction. So I'm now applying this result to how to combine to physical assistant robot. But this is just a juggling task, but I and my colleagues are now applying to rehabilitation application who feel some difficulties to move their limbs. So using such a physical assistive robot, like an exoskeleton robot, and additionally, not only the physical, but the visual feedback, a kind of fake experiences. Oh, you might feel you are difficult to move your limb, but you can move your limb. You can see using the virtual reality system to make such a kind of good fake experiences. So we are now aiming to how to combine such a both virtual and physical experiences to enhance the human's experiences to improve the self-efficacy. So in other words, from the viewpoint of the sense of agency, this is another fake experiences. But this red and blue shows the actual force generated by user itself and the robot assistant. So actually, the human doesn't make not so large force to working. Then almost all the force is made by robots. But if the user's subjective feeling, oh, I work by myself, actually, my robot system assists my force, but the degree of the assistance is very lower. If the human user feel like this, even though the actual state was there, but this is the ideal state to a kind of illusion, good illusion. So how to generate such a good illusion, good fake, is one of the challenges to make the user's QOL more attractively. Okay, so I have to finish my talk. So today I explained this combination of the virtual reality and digital twin, and it might be able to exchange the keyword digital twin of things. This is the current digital twin of human. This is a cutting edge. And I think digital twin of experiences. This is the one of the new challenge for the future direction. In other words, the IoT, IOB, IO behavior, Internet of Behavior is the cutting edge to apply for the human digital twin, but Internet of experiences, not only the human subjective experiences, but the objective experiences by robot. So this is the new keywords to deal with that kind of assisted robot. I will skip about some remaining slide, but IOEX is one of the challenge to estimate the hidden state. Hidden state means the human subjective feeling. I can do it, or my assistant robot doesn't assist my leg, so not so much. This is not observable, but human subjective feeling. How to deal with the hidden, non-observable sensor, non-observable subjective feeling. This is one of the big challenge, and it means that difficult to feedback. So how to make a fake visual feedback, how to make a good illusion of the enhancement. So we are now thinking about several keywords to reach to that goal. Okay, so finally, I'd like to conclude my talk with this matrix. And this was missing earlier, but I am now applying to my platform to enhance both of the human experiences and robot experiences to improve both quality of human and robots. Okay. Hi. So this is the summary of today's talk. I should close my talk, so please just read. And this is my collaborators. Hi, thank you. And you can use my open source software. Hi. Thank you.
exciting talk. Now we have some minutes for some very few minutes. So.
Yeah, thanks for the nice talk. On slide 38, you showed a graphical model. What kind of graphical model is this?
This one?
Yeah, this one.
This is the here is a slum, so it is very conventional.
Yeah, but is it a base net or base filter, or what kind of model is this overall?
Okay. Then, but this, for example, the around here, this is the categorical distribution, and just using the very simple Gaussian mixture model, and category mixed by categorical distributions.
Yeah, but the overall formalism that merges all these submodules together, what formalism is this?
Do you mean the algorithm to calculate and acquire the
Yeah, for example,
hyperparameter?
if you want the distribution over IT, what algorithm are you using?
Sorry.
If you want to calculate the distribution over IT, which is kind of directed to that, what algorithm are you using?
ITU.
Yeah, the variable node there, where your mouse is.
Sorry that I couldn't catch up your question point, but algorithm or some distribution model.
Yeah, but how do you calculate that with what algorithm?
This is actually the collaboration with the Professor Taniguchi Tadahiro, and the more detailed algorithm was proposed by him. So I am charged on the making an interaction experience in VR. So sorry that my detailed understanding is less than his contribution. But the not so complicated, but this is just a simple categorical distribution, and this is pi and alpha is also the categorical distribution, and that is import from the speech recognition area. So just combine as the probabilistical model. I guess my answer might not match to your questions.
Yeah, but then let's continue with the next question. Thank you.
Oh yeah, sorry, but let's go after the talk.
So thank you for the talk. So just going to the first question, asking what algorithms you use. Maybe you're like saying, okay, it looks like a kind of Bayesian model. Maybe the question was, how do you actually emulate the process? How do you come to the value of the variable there? So we see that it's a kind of Bayesian network, right? But how do you come? Is it the deep learning algorithms? Is it kinds of sampling inside?
I see. Hi, thanks. The learning algorithm, we never used the deep learning, but the standard sampling techniques like Gibbs sampling and other sampling techniques to estimate the hyperparameters and the probabilistical model.
Yeah, so thank you. So that also lead me to the next question. So if you're doing sampling, you have like the state space is somehow kinds of big, right? Or your variable are also kinds of big in terms of size and so on. And I don't, if I remember well, I think you say some things like you're also parallelizing your simulations. So you're performing parallel simulations. Could you please elaborate how you perform those parallel simulations? Are they just kinds of simple kinds of parallelisms, or you have something special to meet the times and space constraint?
I see. Hi, thanks your questions. The required time to get the parameter in this application is not so long, like about less than 1 hour. dealing with the data set size is the data size of the interaction is missing in my slide, but about the several hundred interactions in the environment, same each environment. So if the environment, the size of the environment became to be like a 20 or 30, the size of the interaction, my interaction means the utterance, number of utterance might be about several thousand. Then the learning process time is about 1 hour. So currently we never use this parallel computing or accelerating techniques. Not so long time, I think.
Mm.
It is okay for my
Thank you.
questions?
Okay.
So we are running out of time, sorry. So the coffee break already started. Thank you for your talk.
Thank you.